artificial intelligence is rapidly transforming the field of particle physics. This profound shift is particularly evident in the analysis of data from massive collider experiments. Facilities like the Large Hadron Collider at CERN generate unprecedented amounts of information. The characteristics of this experimental data present unique challenges. We are dealing with a sheer volume of data that is almost incomprehensible. Furthermore, the data exhibits an extremely high level of complexity. These experiments involve billions of particle collisions every second. Each collision produces a cascade of particles that must be meticulously recorded and analyzed. Traditional computational tools often struggle to cope with this immense data scale. Their limitations in processing speed and pattern recognition become apparent. This is where artificial intelligence proves to be a game changer. AI offers advanced capabilities for both analysis and interpretation. It provides the necessary tools to extract meaningful insights from the deluge of raw information. This integration is not merely an enhancement, but a fundamental necessity for future discoveries. One of the most significant challenges in particle physics is sifting through vast raw data. The goal is to identify meaningful events, such as the creation of new particles. AI excels precisely at this task due to its superior pattern recognition abilities. Specific AI models are extensively utilized in this domain. Deep learning models form the backbone of many analysis pipelines. Convolutional neural networks, or CNNs, are particularly effective for image-like data from detectors. Recurrent neural networks, or RNNs, also find applications, especially in sequential data analysis. These models empower AI with remarkable capabilities in data analysis. They can identify specific particle signatures with high precision. AI algorithms are adept at reconstructing complex particle trajectories. This allows physicists to trace the paths of particles after a collision. Crucially, AI helps distinguish signal events, like Higgs boson production, from overwhelming background noise. The benefits of this AI integration are substantial. It significantly improves the efficiency of event selection. This means less time is spent on irrelevant data. Furthermore, it significantly enhances the accuracy of event selection. This reduces the chance of missing crucial discoveries. Ultimately, AI allows physicists to focus their expertise on the most promising data. Detector simulation is crucial for understanding experimental results. It allows physicists to predict how particles will interact with the detector components. AI capabilities are revolutionizing this aspect of particle physics. AI can accelerate complex particle interaction simulations dramatically. This reduces the computational costs associated with these intensive processes. Consequently, it enables more detailed and extensive studies than previously possible. Beyond simulation, AI also plays a vital role in optimization. It can optimize detector designs for future experiments. This involves fine-tuning parameters to maximize data quality. AI helps improve the sensitivity of detectors to specific particle interactions. This is critical for detecting rare or elusive particles. Ultimately, AI enhances the overall performance of experiments, making them more effective. The search for anomalies in experimental data is a cornerstone of particle physics. These anomalies often indicate the presence of new physics. Such discoveries extend beyond the established standard model. AI algorithms are adept at identifying subtle deviations from expected patterns. This capability is invaluable in the quest for new, fundamental particles and forces. AI also plays a crucial role in developing and refining theoretical models. By analyzing vast datasets, AI can help validate or challenge existing theories. It can suggest new relationships or parameters within theoretical frameworks. This iterative process aids our understanding of the fundamental forces and particles governing the universe. AI's ability to process and interpret complex data accelerates the pace of theoretical advancement. It provides a powerful tool for exploring the unknown. This collaboration between human intellect and artificial intelligence is driving new insights. Despite its immense promise, the integration of AI and particle physics presents several challenges. Training complex AI models requires vast datasets. These datasets must be meticulously curated and labeled. Such training also demands significant computational resources. High-performance computing clusters are often necessary. This can be a limiting factor for some research groups. Ensuring the reliability of AI-driven results is paramount. Physicists must have confidence in the conclusions drawn by AI algorithms. This necessitates rigorous validation and testing protocols. Another critical challenge is ensuring the interpretability of AI's conclusions. Unlike traditional statistical methods, deep learning models can sometimes operate as black boxes. Physicists need to understand the reasoning behind AI's output. This transparency is essential for scientific validation and trust. Developing methods to explain AI decisions is an active area of research. Overcoming these challenges is vital for the widespread adoption of AI. Despite the challenges, the benefits of integrating AI into particle physics are undeniable. AI is accelerating the pace of discovery. It allows researchers to analyze data more quickly and efficiently. This leads to faster identification of significant events and phenomena. AI is also enabling more precise measurements. Its ability to filter noise and identify subtle patterns improves data quality. This precision is crucial for refining our understanding of fundamental constants and interactions. Ultimately, AI is pushing the boundaries of our understanding of the universe. It provides new avenues for exploring the unknown. The impact of AI will continue to grow with evolving technology. As algorithms become more sophisticated and computational power increases, AI's capabilities will expand. This continuous advancement promises even greater breakthroughs. AI is paving the way for groundbreaking discoveries in the future. It is transforming particle physics into a field where human ingenuity is amplified by intelligent machines. This synergy will undoubtedly unlock new secrets of the cosmos.